my name's Shawn Mahoney. I am an engineer at the National Fire Protection Association. I don't know, how many of you guys were in the last presentation? Okay, a lot of you. So I'm not going to spend a whole lot of time about talking about NFPA. We spent a little bit of time last presentation talking about the commissioning process. One of those parts of the commissioning process of fire protection and life safety systems I talked about was the integrated system testing for fire protection and life safety systems. So during the development of the standard on commissioning, they realized they needed a whole document that just went over how to do integrated system testing. The reason they did that is because A, they wanted it to become a standard on its own, and B, they wanted it to be something that can be easily adoptable. And I'll talk about later about how that worked out sort of after this document hit the streets, what happened to it. So a question for you guys. How many of you guys have worked commissioned systems that were integrated? Any types of systems, right? So buildings are becoming more and more advanced. We've got more and more technology within buildings. And because of that, systems are becoming interconnected with each other and integrated with each other to perform greater and greater functions. The same thing is happening with fire protection and life safety systems. So back in the 1800s, we had a sprinkler system in a building. That sprinkler system had one job. Sprinkler goes off, water goes in the fire, fire goes out. Now, we've got alarm systems, we've got smoke control systems, we've got fire barriers, smoke barriers. All of these systems are now working together to provide the life safety or the fire protection and life safety of a building. We're no longer just relying on sort of one system to perform a single thing. That sprinkler system going off needs to send a signal to the fire alarm panel. The fire alarm panel needs to send notification or turn on specific notification devices. It depends on how the building is designed. It might not turn them all on. It might only turn a certain zone or area on. It's going to recall elevators. It's going to call the fire department. It's going to do a whole bunch of different things. We need to make sure that all these systems are now working together so we can fulfill that fire protection and life safety objective. And that's what NFPA 4 is doing. It's looking at that integrated system testing of all of those systems. The learning objectives, I hope for you guys to be able to understand the integrated system testing process and sort of how it fits into building commissioning. I talked about that a little bit more in the previous presentation, but the biggest thing on how it fits in is it's a key part of the commissioning of fire protection and life safety systems. I'm going to identify the major codes that now include NFPA 4 as a reference document. We're going to go over the various members of the integrated testing team. And then I'm going to summarize the test scenarios, the testing frequencies, and the documentation that's required by NFPA 4. So here's a picture. This is a New York City skyline. The top picture is 1902, and the bottom picture is 2014. So we see a lot of differences in those buildings. They're a lot taller. There's a lot more of them. As I talked about, they're all have a lot more technology within them. And same with that fire protection and life safety. All of these systems are working together within these buildings now. We're no longer relying on those single systems to do that one job. So here's an example of the documentation that's required sort of in buildings today. We've got engineering, contractor, and architect affidavits stating that everything's sort of designed and installed per the requirements, the building codes and standards. We've got sign-offs from the inspectional services, fire department, fire alarm, generator, contractors. So all the contractors are signing off on their work. We've got security signing off, building management systems, they're all signing off, and they all have their own documentation. The one thing that we don't have is sort of a document saying that all of these separate systems that may have, in their own vacuum, have been tested to work exactly as intended, we want to make sure that now all of these systems are working with each other correctly. And that's where the integrated system testing and all the documentation that's created from the integrated system testing is going to come into play in the documents for the building. You're now going to have something to look at that says all of these systems were tested in all of these specific scenarios and everything worked as intended. So here's an example of some of the fire protection and life safety systems that you would see within a typical building. So we've got elevators, fire doors, fire dampers, all that's covered by NFPA 90 and ASME A17.1. We've got other systems that could be standpipes that are covered by NFPA 14. Maybe you've got kitchen suppression systems over the kitchen hood, that's covered by NFPA 96. Smoke control systems, HVAC control, that's covered by NFPA 92 and NFPA 90A. Fire and smoke doors and dampers, again, covered by NFPA 90. We've got emergency communications. Those are what's provided to the fire department in order to communicate with each other or the fire brigades that are located in the facility. That's 1221. Then we've got NFPA 72 that covers the fire alarm systems. And then NFPA 13, which covers the sprinkler systems within the building. So all of these systems have their own design and installation standard. Each design and installation standard is telling you how you need to design the system and then how it needs to be installed. And then it's got specific testing that needs to be done that tells you what you need to do in order to test the system to make sure that it's been installed correctly. So, for example, we've got, say we have a fire alarm system, and I like to just use the kitchen hood because a lot of people don't think about it when they're thinking about integrated systems. So we've got a fire alarm system and a kitchen hood. They're both connected to each other with a relay. So when the kitchen hood system goes off, it sends a signal to the fire alarm. Then the fire alarm knows to either initiate notification, or call the fire department, recall elevators, whatever it's supposed to be doing. When you're doing an acceptance test and a yearly test, maintenance test of the kitchen hood system, you're making sure that it's not clogged, all the mechanisms on it work correctly, but there's nothing that's making you test the signal going out of it, going to the fire alarm system. Again, when you test a fire alarm system for its yearly test, there's nothing saying that you have to go to that kitchen hood and initiate a signal from it to the fire alarm panel. So what we're looking at, what we're trying to figure out is working with those tests is the actual connection between them. So that relay that exists between the kitchen hood system and the fire alarm panel, we want to make sure that that's working. But the way the scopes of all these design documents are written, they can't cover other systems. So they can't require testing of other systems to make sure that connection's working. So that is why NFPA 4 was created. So NFPA 4 essentially covers all of those, just the connections between the systems. So this is one thing, or a good time to sort of talk about what I mean by just the connections of the systems. So a lot of people will get scared when they hear integrated system testing needs to be done in my building. Maybe you've already done testing on, say you have a smoke control system, right? You've already went through, you've already measured all the CFM of all the fans. You made sure that they were all installed correctly and are providing the correct flow and things like that. When you have to come back per NFPA 4 to do an integrated test, I'm not going up and measuring the fan and making sure you're getting the correct flow. That's a performance issue. That's something that's covered within the design standard. So that's not something that me covering integrated testing per NFPA 4 needs to look at. I'm looking at, did the fan turn on when the fan needs to turn on? Those are basically what I'm looking at. And did it turn on within the right amount of time? I'm not making sure that, does the fan have the correct number of belts on it? Does the fan, create the right amount of CFM? I'm not looking at that stuff. I'm just making sure the fan turns on when specific devices tell the smoke control system to turn on. So another thing to talk about is NFPA 4 is covering those interconnections between those systems. I say interconnections and integrations. So you have your interconnections of systems. So those could be like your switch, so relays between systems. That's an interconnection. You can have a data connection, so whether you're sending information over an Ethernet or wirelessly or something like that, that's a data connection. You're sending multiple bytes of information back and forth. But systems don't necessarily have to be interconnected for them to be considered integrated. So we'll take the example of a smoke control system again. So if you have a smoke control system within an atrium, one of the requirements is that you separate the atrium from the remainder of the building with a smoke control barrier or a smoke barrier. In order for the smoke control system to work correctly, the smoke barrier needs to be maintained. That now means that the smoke barrier around the smoke control system is integrated with the smoke control system. So that would include door closers, dampers, but it also includes the wall itself. So as part of that test, you need to be looking at and making sure that the walls aren't damaged and they're going to perform as intended. A lot of that information you're going to get from the testing that was done on the fire assemblies themselves. But it's just one thing to think about is that we're not just talking about systems that are connected with each other, that are electronic, that are doing something. It could be as simple as a wall and a door. We need to make sure that they're integrated and work correctly. Another thing is they don't even have to be a system, or they don't necessarily have to be something other than a person. So say I like to use the example of like a prison or something. If you were in a prison, a lot of their fire and their life safety tactics are not to just, if there's a fire, they don't just let everybody out of the prison. One of the things is they make strategic decisions of what doors to open, where to move the inmates, and things like that. Because of that, those guards are part of the integrated system. So you need to document what those guards are doing at certain times, how they're being trained, and things like that. Also how they communicate. Maybe they're using walkie-talkies or something like that. You need to be making sure that all of that's going to be working. So it does kind of make you start to think about what types of systems are actually integrated, and it could be a lot of different things, especially in a lot of complex buildings or that have complex fire protection and life safety systems and things like that. So now a little bit of overview on NFPA 4. The biggest thing is it's not a prescriptive code. So as I talked about with NFPA 3 on the commissioning, it's not going to tell you what you have to do. Like, it doesn't tell you exactly how to do it, right? Like if you went into the building code and you said you had a room with 100 people, it's going to tell you how big the door needs to be to get out. That's the building code. That's prescriptive. NFPA 4 is not prescriptive. It's telling you specific things you need to be doing as part of that process of the integrated testing, but it's not telling you because you have a sprinkler system and a fire alarm panel and a kitchen hood, you have to test for water flow and make sure that the kitchen hood sends the signal to the fire alarm and make sure that all this happens. It's not telling you all that specifically. It's telling you that you need to make sure that they're all working as intended. And the reason for that is sort of the same reason with NFPA 3 for commissioning, is they wanted this document to be scalable. They wanted it to be able to be applied to multiple buildings. It would have taken them forever to put all the specific requirements in this for each specific system. And they would most likely forget a lot because systems are constantly being created and there's new systems every day, right? So I talked a lot about the difference between acceptance tests and integrated system testing. The acceptance test is on that single system. Integrated system testing is looking at the connection between them. And then commissioning, which I talked about previously, commissioning is that systematic process of documenting that all the systems were designed and installed per their requirements of the owner and requirements of the standards. So as part of that commissioning process, you're required to do integrated testing. So that's where commissioning and integrated testing kind of come into play. A lot of times when we would talk to people, and still, when we say integrated system testing, people instantly think that that's commissioning. So it's a lot of misconceptions that people have between integrated system testing and commissioning. They think they're synonymous. Integrated system testing does not provide all of the documentation that a commissioning process would. So we'll talk. I'll talk a bit coming up about the testing team, sort of who's on the testing team. Again, very scalable depending on the complexity of the building, how big your team's going to be. We'll go over the test plan, basically just who's responsible for writing the test plan, the different types of scenarios that are involved, the frequencies in which the testing needs to be provided, and the documentation that's needed. So the integrated testing team. I talked about that it basically is open and allows you to be very scalable. So the testing team, the only real people that are required on any team is the owner of the building, and the owner, that's the only real requirement of the owner is to hire the ITA. The ITA is the integrated testing agent. I talked about that person a lot in the last presentation, but essentially that person is he or she is experienced and knowledgeable in the design, installation, and maintenance of these and the interconnection of fire protection and life safety systems. That person is responsible for creating the integrated test plan, making sure the whole team is involved in implementing the test plan, and then documenting that test plan. So the ITA, once they're hired, is then responsible for creating the team. So depending on the systems that are involved, you're going to have like one or multiple people who are responsible for the installation and maintenance of each fire protection and life safety system. So say if we were in a building with a sprinkler system and a fire alarm, you would just have the sprinkler contractor, the fire alarm contractor, and the integrated testing agent. Then when they do their testing, you would have the authority having jurisdiction come in to witness the test, most likely because the integrated testing would be done per requirement from the authority having jurisdiction, and they would need to witness it being tested. Sort of similar as an acceptance test. In a lot of cases, for more simpler buildings, the authority having jurisdiction might allow you to just do the test and provide them documentation. But the authority having jurisdiction is sort of considered part of the testing team for those types of tests in which they need to be there. So, who do you think would make a good integrated testing agent? Anybody? Someone who has to be experienced and knowledgeable in multiple systems? Yeah, so one of the biggest persons who would perform the integrated testing agent role would be like a fire protection engineer. I talked about like a fire alarm contractor would be pretty good. Depending on what systems are involved, there might not even be a fire alarm panel within the building. So maybe not necessarily a fire alarm contractor. Again, it all depends on the types of systems that are installed within the building. But per NFPA 4, there's no requirements for specific certifications. So similar to the fire commissioning agent, you don't have to go and get a specific certification. But that's, as of right now, there's no requirement. I can't say that there won't be one down the road as this becomes more and more of a thing that's being done. So that's just one thing to look at. So I talked about sort of that scalability. So two buildings on the screen right now. We've got a Wawa, so like a convenience store, right? And then Mandalay Bay, which is a casino. So those two buildings are going to have different types of systems. And they're going to be more, essentially the systems with the casino are most likely going to be more complex than the systems within the Wawa. So the integrated testing team in the casino is going to be much larger than the integrated testing team within the Wawa. So I said in the Wawa, it could be as small as the general contractor and the AHJ, if the general contractor is allowed to touch everyone's things. That becomes an issue when you start doing integrated testing because people don't like people touching each other's systems. But if it could be as simple as that, it could just be two people. You get into like a building like the World Trade Center, it could be thousands of people. It all depends. But it doesn't necessarily equate to the size of the building. You know, just because the World Trade Center is a big building, that's not the reason why there's 1,000 people on the integrated testing team. Because you could have a Wawa, and then you could have like a high security bank, the same size. The high security bank could have a big security system, a lot of door locking, many alarms, have a lot more systems that are involved in the life safety systems and fire protection systems, and it's going to require a lot more people than the Wawa that's the same size. So basically you're looking at the complexity of the building and not the size of the building. So if you had a giant warehouse, it could honestly just be 1 or 2 people doing the integrated testing. So the most real direction as far as the testing goes is you need to test for a minimum of 3 things within a building to initiate your integrated systems. The first one being the presence of smoke. So presence of smoke is going to set off smoke detectors or duct detectors or whatever type of smoke sensing or beam detectors within a building. The next one is water flow. So water flow going off in a sprinkler system, you need to test what happens after that. And then the other one is the loss of power. So one of the biggest things within integrated testing is most life safety systems are required to be provided with emergency power. So you need to test all of these systems. Not only do you need to test the integration of the systems under normal power, but you now need to test all these systems under emergency power. So you need to test for the loss of power. And it can be a combination of all of these. If you have buildings with other types of detection systems, so manual pull stations, maybe you're in like a big warehouse and you've got IR detectors. Maybe you're in a chemical facility and you've got atmospheric monitoring sensors. There's a lot of different things that can be involved that would initiate your different test scenarios that you'd have. The other thing is that the authority having jurisdiction might have different requirements than you as the integrated testing agent would have as the type of scenarios that you'd want to be looking for. I used to do work in Boston. We did a lot of smoke control testing. And it seemed like every time we brought Boston Fire Department to come in and witness our testing, they'd throw another curveball at us. So we were constantly getting more and more scenarios that we'd have to be testing. We'd have to drop power, pull the fire alarm, bring the power back, crazy things that they'd have us do. So those are all things that you need to be thinking about that maybe you wouldn't necessarily be thinking about as yourself. So bringing the authority having jurisdiction on ahead of time to find out what they're looking for is very important. And that's one thing that you'll see a lot. I mean, even with the commissioning process, it's recommended to have the authority having jurisdiction right there from the get-go. So that'd be the building official or the fire marshal. They're there right when you start developing your plan, so they can give their input ahead of time rather than right at the last minute when they think you did something completely wrong. So the next part I'm going to talk about is the testing frequencies. So this was one thing that was pretty contentious, I guess, when the technical committee was coming up with these requirements within the standard, because they wanted to be careful to make it easier for this standard to become adopted. So they didn't want it to just all of a sudden become a requirement for all buildings to be integrated, have integrated system testing. So one of the things is for existing buildings. So upon the adoption of NFPA 4, so once a building code requires you to do integrated testing, you have up to 5 years to develop an integrated test plan for your building. It doesn't say you have to do the test plan, but within the test plan that you develop, you have to develop a periodic time frame for doing your testing. Then that all has to be approved by the authority having jurisdiction. So for example, say I had a building, NFPA 4 got adopted. I now have 5 years to write a test plan. I'm the integrated testing agent. I would say, okay, we need to do periodic testing and we'll do it every 5-10 years. 5 years is generally what people are doing for integrated testing, and that's why that 5-year mark is there for developing your test plan. But say I wanted to make it 100 years. Nothing in the standard says I can't, but the authority having jurisdiction is probably not going to accept that I will do integrated testing in 100 years. So that's where the authority having jurisdiction comes into play once this gets adopted. And it was specifically written like that, so they didn't require that every building within the jurisdiction, once they adopted it, had to go out and do all this testing. They're still going to have to do some type of integrated work to figure out what their plan is going to look like. So then we have initial integrated system testing. So new construction building, you're going to do integrated system testing on whatever building is required. I'll talk about coming up, but the building code is going to require you to do it buildings with smoke control systems and high rises. So if you're in a state, they adopt the 2018 building code and they don't change any of those sections, you've got to do integrated testing before you get your certificate of occupancy. So that's for initial. Once any building has been integrated tested, so once you've done an integrated system test on a building, you then go into a periodic cycle. The periodic cycle is defined in the test plan by the integrated testing agent. So whatever time period they put, every 5 years, every 10 years, you've got to do an integrated test again. But then also there's triggers in which you're required to do integrated testing. So say you add a new integrated system, you modify an existing integrated system, or you get rid of an integrated system. If you do any of that, you have to check everything that was affected by the work that you've done. Essentially, if you add a new integrated system, you've got to test everything. But if I went in and I changed some parts of my fire alarm panel, maybe added some devices or replaced some devices, I'm only required to go in and test sort of the affected area plus a maximum of about 50 devices. But it's a percentage of, I think it's like 10% up to 50 devices that I need to be testing. So that would be a building that's already had integrated testing done. Those are requirements for when you need to be doing it again. Essentially, anytime you're going in and playing around with the connections, you need to test it again to make sure you didn't mess anything up. So then, there's some requirements for the documentation that you have to be providing. There's a lot of reasons for why you'd need to provide the documentation. So we're not just providing documentation for the sake of providing documentation, right? The authority having jurisdiction wants the documentation to make sure that these systems were tested as intended, right? The ITA wants to get all this documented to make sure that they're essentially covering themselves for all the work that they did. The owner is going to want this documented for the reason being that they paid someone to do the testing. The other reason being that I told you about the periodic testing, right? So the integrated testing agent is going to write the test plan. They're going to tell you all the different scenarios that you need to do to test the integration. Then they're going to do it. Then they're going to give you all the documentation. 5 years from now, I may not need to hire that ITA again. I, as the owner, might be able to, if I'm educated enough, might be able to perform all the tests myself. So that's where it's good to be documented correctly, because if nothing changes in the building, you've already documented all the different things that you want to test. You just need to test them again. So you could either hire a third-party testing entity, or you as the owner yourself can go in and do the testing again. But the authority having jurisdiction then does have to accept what you've done, because essentially that is still a requirement of the authority having jurisdiction, because the authority has approved your test plan, which has that periodic testing within it. So there's about 5 main documents. We've got the test plan itself. That's going to go over what you're doing in order to make sure that your systems are integrated correctly. You've got your input-output matrix, which is shown here, a sequence of operations, an issues log, and a corrective action report. So the test plan is basically going over the different types of how you're going to be doing the testing, the different types of scenarios that you're going to be running. Then we've got on the screen here, we've got the input-output matrix. You guys are probably pretty familiar with this. Have you guys seen something similar to this? Do you guys have, I'm not necessarily, is this like HVAC stuff? Do they have their own sequence of ops? So this is something that you would generally see on a fire alarm submittal for fire protection systems. So that's one thing that the fire alarm contractor is going to generally submit this to the ITA. The ITA is responsible for going through and making sure that it all makes sense, and then is probably going to have to send it back to the fire alarm contractor because there's probably going to be something wrong. A lot of people pay a lot of attention to these when they're making them, but they soon will because they're soon going to have to make these things work. So the input-output matrix is basically showing you for every input into a system what is happening. Then we've got a sequence of operations, which is basically breaking down every input, and then you have all the outputs. The good thing for a sequence of operations is it makes it easy to document when you're doing the testing. So in the sequence of operations, I'd have a line where it says pull manual, pull station on first floor. It's going to tell me all the, say, 5 things that need to happen. During the testing, you have each person sign off when they see everything happen. Then you have the sequence of ops that is essentially documenting all the testing that you've done. Essentially documents the fact that that matrix is working correctly. And one thing that you need to note on your sequence of operations when you're doing the test is how you perform the test. So whether or not it was you created the test scenario. So if you have a water flow device, there's 2 ways to get a signal to the fire alarm panel from a water flow device. The first one being to flow water through the pipe. That's the preferred method, right? Because you're testing everything. You could also just manipulate the connections and get a signal to get sent to the fire alarm panel. That is not necessarily preferred, but you need to be noting how you got that signal to be started. And that has to be noted on the sequence of ops. The other thing to be noting is whether or not you did it under normal power or emergency power. So essentially, you're going to have to do a lot of these tests twice to make sure everything works under emergency power. So then we've got the issues log. The issues log, you guys are probably all familiar with an issues log. I see head nods, right? Yeah. So anytime you see something that's wrong, you write it in the issues log. You then assign it to someone. They perform a corrective action. Then you have the corrective actions report, which tells you what you did to solve the problem. And then you close out the issues log, but it's, obviously put in there about what was wrong, and then corrective action tells you how you fixed it. That's good for a lot of reasons. One of the biggest being like warranties, so if you have issues with warranties. Another thing is tracking common issues. So maybe you had to do something in a specific set of rooms after your fire alarms were installed. And then you had to go back into those rooms and do something to the rooms and then reinstall your fire alarm system, so your notification devices. If you start having an issue in a bunch of rooms that you had to do something in, you're going to realize to go check all the rooms that you had to go fix something else in. It's just a good way of keeping track of what common issues are happening within the building during your integrated testing. All right, so now here's the important part where most people care about this, is the fact that in the 2018 editions of NFPA 1, which is NFPA's fire code, NFPA 101, which is NFPA's life safety code, NFPA 5000, which is NFPA's building code, along with the 2018 edition of the International Building Code and the 2018 edition of the International Fire Code, all require that some form of integrated system testing be completed. Basically, here's the text on the screen. This is the text from NFPA 101, which is the same as the text in 5000, and then the 101 text is extracted into the NFPA fire code. What this says is you have basic testing that you need to do. The basic testing, as it says, is anytime you test a fire alarm system, you need to then make sure that any of the integrated systems with it the intended functions are performed. It doesn't tell you how to do it. It just says you have to look at it and make sure that everything, that you're getting the correct responses. So basically I would look at it like this. If I had to test my kitchen hood, so I do all the acceptance testing on my kitchen hood, the other thing I have to do is now send a signal from the kitchen hood to the fire alarm panel and make sure that the signal gets there. The part where it gets a little tough is at what point, do you necessarily have to stop? Because do I now need to make sure that all the systems of the fire alarm panel, all the systems off of the fire alarm panel, like all the correct responses are still happening? Because that's technically a response from the kitchen hood suppression system. So that's the part where it's going to kind of be up to the AHJ to determine at what point. Are they just looking to make sure, okay, the signal between what you've tested and the fire alarm panel, that signal works? Or do they want you to test that whole sequence of ops and all the different outputs of the fire alarm panel? That's where we don't necessarily know. It hasn't, the 2018 editions haven't actually really been adopted anywhere. And it could become something with a lot of fire alarm testing, because if you're testing a fire alarm, now you have to test the response of every system connected to it, which essentially becomes almost a full-blown integrated system test. To what degree the authority having jurisdiction is going to accept your testing, it is all up to them. But now we've got NFPA 4 testing. So NFPA 4 testing is you need to follow the procedures within NFPA 4. So you need to have an integrated testing agent, you need to have a team, you need to document it all per NFPA 4. That's if you have a building with a smoke control system as one of its integrated systems, which a smoke control system is an integrated system itself, or you have a high rise. So if you have either two of those buildings, you're required to do integrated testing per NFPA 4. And essentially that is, you need to do that before you're getting your certificate of occupancy. That was put into the fire code. The fire code is applicable to existing buildings. So now, go ahead.
So I'm assuming they're amending the fire code to say reference NFPA 4 for testing, or?
Well, this is in the fire code.
Well, because in 909, like you need to test with an approved agency and they need to be able to do the other.
That's for like smoke control and stuff though. Correct. This is any integrated. Yep. Yeah, so I don't actually know how they necessarily tied those within the fire code, but I would say yes, you have to, essentially they're gonna tie to each other, where it's gonna tell you need to follow 4 for any of your smoke control tests. Okay, so basically what this is saying is anytime you have a high-rise building or a building with a smoke control system, you're going to need to be doing NFPA 4 testing. So as I was saying, is this was put into the fire code, and the fire code's applicable to existing buildings. So then that pushes you back to 4, and 4 says you need to have that test plan made for existing buildings. So once NFPA, any of these additions of the codes get adopted and they don't amend any of those sections, all existing buildings are going to have an integrated system test plan. So it's going to be a good opportunity for someone to get a lot of jobs out of doing all of that within the first 5 years. Same basic concept. This is the building code and the International Building Code and the International Fire Code. I think the text in here is a little bit easier to understand than the way it is in NFPA. But basically it's just saying is you need to test the intended response of a subordinate fire protection and life safety system. So you need to, and the words they use is verified. Anytime testing of the initiating system is conducted. So probably their way around that is looking at the initiating system, so systems going into the fire alarm panel, but the way it doesn't necessarily say anything about the fire alarm panel. And then again, it says high-rise buildings and smoke control system, buildings with smoke control systems, you have to follow the requirements per NFPA 4. So does anyone have any questions on sort of what I've been over so far?
A quick question. So let's say you have a small smoke control system.
Yeah.
Does that mean you have to do integrated testing for fire doors and the kitchen hood system? You have to do everything,
Yep.
not just that smoke control system?
Yeah. If where a fire alarm system is integrated with a smoke control system as outlined in 909, integrated tests shall be performed per 4. Yep. Not just for that system. Because that system already technically needs you to do the special inspection. No, they want you to make sure that everything is working. So this is the other thing I wanted to get to. So prior to anything, I just want to talk about sort of where this is going. And I like to tell people, like, this isn't the end of, like, integrated testing per 4 isn't just going to stop at high-rise buildings and isn't going to just stop at buildings with smoke control systems. Because actually, when the 2018 editions of these codes came out, they required testing. It just said any integrated systems within a building must be tested per 4. That is all it said. They submitted what's known as a temporary interim amendment. And that amendment added all the extra requirements for the basic testing not needing to be per 4 and only requiring it for smoke control in high rises. The reasoning behind that is there was a lot of hesitation from a lot of people about initially just requiring it for all buildings. But it is something that is down the road, because that's the way it was initially put in. I wouldn't be surprised in the next cycle or the cycle after that this is all of a sudden required for everything. So that's just one thing to keep your mind on, or keep your eyes on, because it's happening. Just because you might not work with high rises or buildings with smoke control systems, it's going to be something you're going to see happen. Do you have a question?
Like you mentioned that NFPA 4 is already in the fire code. So is that accepted by the jurisdiction?
So it's in, NFPA 4 is in the 2018 edition of the fire code. No, I don't think anyone's adopted 2018s yet. So as of right now, no one's requiring it. But as soon as they start adopting it, which could be soon, it's gonna be required, provided they don't amend it out or anything like that. Again, just a quick plug for the revision process. You guys are able to go in and provide the technical committee with, at this point, it's public comments. So you're allowed to provide them comments on any of the changes that they've made from the first draft. So their first draft for the 2021 edition is posted, and you can go in until May 8th and provide as many comments to them as you want. Tell them to look at specific things. The only issue is that where we are in the process now, they might not be able to add a whole lot of new material, but they can always bring that back into the next cycle. That's just the way the cycle works. But you guys are able to go in and provide whatever comments that you want, especially because this is something that is probably going to be affecting you guys, just like NFPA 3 on commissioning. And then just like I said last presentation, we have a workshop on integrated testing. The next class is actually not the one in Illinois. The next class is in San Antonio on June 15th, which is a Saturday. That's before our conference and expo. And then we've got a class in Tarrytown on May 23rd. We do have some fact sheets and additional information on our website, nfpa.org/4.
I think you mentioned about qualifications. And did you say that you didn't really need any qualification certifications for the testing?
So there's requirements for qualifications, but the qualifications being that they need to be experienced and knowledgeable in the design, installation, and maintenance of the systems. It does not require you to have a specific certification.
So does it allow, like say the fire alarm contractor who's installed the work to be?
Yep, they can. And then, but it has to be approved by the authority having jurisdiction. So whoever it goes to, whether it be the building official or the fire official, they have to approve the work that's been done. So, but yeah. The thing is though, when you're doing your fire alarm, your annual fire alarm testing, You generally don't have the elevator contractor there. You don't have the HVAC contractor. You don't have the person in charge of the kitchen hood. So a lot of like what you just said is what I hear almost all the time. Like we've done that already. And I'm like, you probably have done it already, but it hasn't been documented, or you haven't been able to do a specific thing because one guy couldn't be there that day, didn't want you to touch what he installed. They didn't, you know, the big thing is that like people don't like each other playing in each other's sandboxes. So this is trying to solve that issue by forcing everyone to get together, and like you just have to do it. Yeah. So a lot of this stuff isn't new. It's stuff that's should be people are already thinking about doing it. Yeah.
Well, one of the questions I would have then is when an owner's looking at trying to put a budget together for this, the integrated testing agent develops what's going to be tested and how it's going to be tested, and then gets the approval of the authority having jurisdiction that that's acceptable. But there's no prescriptive.
No.
So how do you budget that when you have no clue what the agent may or may not want to do? Because as you said, you can have an integrated system where, well, the size of the doorway needs to be verified because that's part of life safety. It's kind of an open can of worms, it seems, as far as defining the scope. But we're the ones who have to put a budget, talk to the owner about it, and get him to allow for contingencies. But I'm not sure how you define that scope.
Yeah, I mean, it is tough, and I would say it's something that the authority having jurisdiction should know that this is coming down the road. Not just that specific project, but they should know that this is something that needs to happen. And they should sort of understand what they're allowed to, what they are and aren't allowed to sort of require. It's tough to answer that question. I'm not sure, especially if it's like a first project in a jurisdiction. I would just need to talk. You just kind of talk to the authority having jurisdiction and find out, do you have any additional requirements that you're going to need to see other than sort of basic verification? Yeah.
Okay, and so then the testing procedures could change drastically in 5 years because you can catch 2 code cycle revisions during that time. You might have to throw out that entire thing and start all over.
That's with every standard now.
But this is a mandated one that says every 5 to 10 years, or no more than 10 years, you're going to have to redo this.
Yeah, but the sprinkler, you have to, every year you have to do the sprinkler, every year you have to do the fire alarm, and that changes every 3 years.
Yeah, but not so drastically where you're replacing the system.
You shouldn't have to replace the system for an integrated test. You're just making sure you're only testing to make sure that it's working as installed. Just because the requirements in the design standard change doesn't mean you have to change your system.
That's up to the authority.
No, NFPA 4 does not require you to change the design of a system. You're just looking at the connection of the system. You're not looking at performance. So there's no way they would require you to change the system unless it didn't integrate properly. Like unless something in the system broke, you wouldn't have to change stuff.
And I would add, maybe you can clarify this, to me this is code, right? So somebody has to write a specification that says, you will test this integrated system, you will do it by NFPA 4, which means you have to bid the specification.
Yeah, that's a good
Grant.
Yeah, you just don't have a clue until the agent turns
You
out
have
to
to
test.
do the NFPA 4, you have to do the test, it's your commission.
So it gets tough when it comes to providing bids because it's hard to determine the cost. But also, the one thing, at least when I talk to like fire alarm contractors and sprinkler contractors and stuff, they usually will, because they know what the acceptance testing is, they'll provide their bid and just says includes all required testing. But if they did that and then didn't realize that acceptance or the integrated system testing was one of those required testing, they now have to do it, and it's in their bid. So usually it's added as a separate line item, and then you need to have the conversation with the owner and everyone involved to understand how much it's going to cost. And once it starts to happen more and more, you're going to start to understand the costs of it. It's just tough because this is something that's brand new. It's not that people aren't necessarily doing this already. There are sort of costs that people have spent for it, but it's hard to tell with different types of authorities what they want to see.
To your point, you made a point that the authority having jurisdiction is really the one that sets the scope and the standard and what you're going to do and what you're not going to do and what's acceptable. Because in the end, they're the ones that are going to either accept your report or reject it and so forth and so on. So we've done some tests in some cities where the authority having jurisdiction is they're up to speed, they're smart, they're writing our test criteria that we have to follow as a third-party inspector to give them the report that they will accept. And as a note to the wise people, that authority requires you to test an emergency power by pulling power to the building, not just changing the transfer switch over emergency power and leaving the current power running. What that makes the owner do is he loses anything in permanent power that's not on an emergency generator, and they look at you and go, wait a minute, time out. We're not doing that test. I'll go see the fire marshal myself, but we're not shutting this plant down, or we're not shutting this hospital down, or we're not shutting this. So just FYI, make sure you know what you're doing, and don't go out there and do a half-hearted test and then submit it. If you're going to get eaten alive if they don't accept it, and you're going to go back to the owner and say, I didn't know we had to do it this way, and you're going to be in a bag of harm. So.
Yeah, and definitely if you can, I would have the authority having jurisdiction review your test plan prior to completing it, because
This is what I'm doing, this is what I think you want, this is what I think you're asking for, this is how to interpret your plan or your scope or your spec or whatever, and get to know them, because that's the only way you're gonna get through it. And then if the owner has a problem, you gotta really tell the owner what's going on. A lot of times, I mean, I've got several buildings that they're just stuck. That authority having jurisdiction is trying to pull their seal and they're saying, great, we'll go talk to the mayor or whatever, because you're not shutting this plant down, keep our certificate of occupancy, you're not doing it. So it's just a big thing right now, but like you said, things are changing and there's a lot of impact as a result of that.
yeah, and you just need to learn how to operate. It's gonna, as it starts to happen more and more, it's gonna start to become more common.
Thank you.
So the IBCC required special smoke inspector.
Yeah.
Is this going to pass as the special smoke inspector under the IBCC?
I'm pretty sure it should, yes. It follows the same, except for the fact that you need to follow the specific tests that the special inspector needs to be doing. So actually, now that I think about it, because the special inspector needs to be looking at like the belts and things like that, that's not necessarily covered in 4. So the best thing is to probably try to loop them all together, but I would say that they're not necessarily exactly the same.
That goes back to talking to the AHJ and being sure that you can or can't integrate those two in one test.
Yeah, and they're going to come up, because, I mean, the authority having jurisdiction is going to have to deal with all this paperwork now. So they're going to hopefully try to figure out a way to make it better. And you're going to see it more in big cities, where they have a lot more high rises and smoke control systems and stuff, that they're going to have a specific process they want you to follow. Down there, actually.
So NFPA is generating these standards that's saying you need to test these systems.
Yeah.
Who establishes the pass criteria? And how do we get to a standardization that bridges the pass criteria between not only NFPA, but all of the other, I guess, standards like ASHRAE and IEEE and everyone else to get this all sorted out together, that we have one standard passing criteria for your testing requirements?
So the first answer is that the pass criteria is determined by the ITA, but the ITA is determining the pass criteria based on the design and installation standards of the specific systems. There's not, because you're not looking at performance of the systems, most of your pass criteria are either did it turn on or did it not? And some of them are how long did it take to turn on?
Exactly. So, and for the sake of simplicity, like if you're testing a smoke detector, does it take a half a can of smoke or, a second of it?
That's not standardized anywhere though.
I'm just saying, from the standpoint of how long does it take for a certain specific reaction, action-based thing? Is NFPA even exploring that to standardize those scenarios or not?
I think at this point, I mean, they're always trying to do that. There's no like big initiative to try to do it. I think the technical committees always understand things like that are happening. I know like the can of smoke thing, they've written stuff in the fire alarm that you can't use like the magnets to set off stuff. So they do have some requirements, but no, there's no like one standard, 2 seconds of smoke for however long kind of thing. Again, that comes down to the authority having jurisdiction. If they're witnessing the test and they don't like how you're initiating it, it's up to them. Yeah, I mean, I wish I had a better answer because those are a lot of the things where people have a lot of the questions.
Those are the things I think as a commissioning service provider, we get put up against a lot of challenges in the field by the differences of the testing requirements and the establishments of that passing criteria.
Yeah, because we get it even if you look at like the special smoke inspection, it's like the fan needs to turn on within 60 seconds. It's like, okay, does it need to be at full power or does it just need to start spinning? Like, yeah, I completely agree that some stuff is a little vague like that. Did you?
Yeah, I kind of since we are not there yet, but the way it has been done, it's so subjective from the point of view of authority having jurisdiction. They have to approve the test plan, they have to see what is acceptable, what is not. It's gonna be, how it's gonna be happen, authority having jurisdiction.
How is it gonna happen with it? I mean, you're gonna have to get them involved and talk to them and they're gonna have to understand the project and it's just, you're gonna have to talk to them. That's the way this was written in order for it to be scalable and applicable to all different types of buildings is they had to write it in this way that everyone needs to sit down and figure out what you need to do in order to test these systems. So the authority having jurisdiction needs to be there or they need to approve what was decided, prior to going forward.
Without any established criteria, authority having jurisdiction would be sometimes depending on who the talks. There is subjectivity there.
What? Who's the authority having jurisdiction? It depends who's enforcing the code. So if the building code gets adopted and not the fire code, then it becomes, say, the building official. But if the fire code gets adopted and not the building code, then it becomes the fire official who's the AHJ. So it depends who's enforcing the code. Right there?
Shawn, how are the state fire marshals, are you guys lobbying the state fire marshals to implement 3 and 4 as part of their codes? I mean, do you foresee it? For Georgia, for instance, obviously the state fire marshal will dictate what NFPA code is applicable as part of their codes, or what standard NFPA standard is considered code in the state of Georgia, the state of Florida. What is NFPA doing as far as implementing 3 and 4 in states around the U.S.?
I mean, the biggest thing is we're always pushing the adoption of our model codes. So the adoption of NFPA 1 would bring in 4. That was the way, sort of the technical committee, so there's a difference between the technical committee that developed the document. Those are volunteers who developed the document. I work at NFPA as a staff member to help make sure that all happens. The technical committee was like, we need this to become a standard because we want it to get adopted. So that's why it got split into a standard. Then they all kind of worked together to sort of lobby it to get put into the codes. And then us as NFPA, we want to make sure we want more people to adopt our specific codes and standards. So we're just pushing to get NFPA 1, 101, 5000 to get adopted. But it'll still happen if someone adopts IBC or IFC if we're just talking about NFPA 4. But yeah, that's kind of the extent, always trying to push to get our codes and standards adopted. And then obviously the technical committees are always so technical committee members can provide or submit public inputs and public comments to other documents so they can try to push that document into other documents as well. So that's another way out could happen as well. Any other questions? All right, I think we're good. Thank you.